Hey everyone, welcome back. This is Vivek Bharata. Last video is about NestJS crash course. This video is kind of a follow-up to it where I will be covering database connection and will be following a repository pattern for it, and I will be using MongoDB. However, if you want an SQL based database like MySQL or Postgres, do let me know in the comments. I'll have a separate video for it. Now let's get started. You guys might have already familiar with Mongoose, and NestJS supports Mongoose out of the box and they have their own abstract version of it. So let's first install the dependencies, and that would be npm nestjs mongoose and mongoose. That's it. Alright, package has been installed, and I already started a MongoDB instance from the Docker desktop, and also I have a MongoDB compass. Let me just connect to the database, and we have nestcc. This is the database we'll be using. Okay, and inside there is a users collection already. Now let's add the connection string so that we can just connect to the database, and that would be in the app.module, as this is a very root module of the whole NestJS application. And here in the imports we'll be using Mongoose module. Mongoose module, and syntax is like for root. And here we need to pass the connection string URI, and that would be this one. This already had a setup. So this is the username, and this is the password, and this is the address of the MongoDB server. And this is normally the connection string. Outsource, we are using it as admin because this specific user has been created with outsource as admin. Alright, that's pretty much it on the connection part. Remember in the previous video I defined that there is an entities, and I also mentioned that this can actually be used as an ORM model. So we'll just update this file in a way that this will be a Mongoose model file. To begin with, let's just remove this one because underscore array will be auto-populated from the Mongo database. And also for each field, the main decorator we just need to add is prop from the NestJS Mongoose, if you can see. So you can just hit enter. This is a decorator. Let's just add this for the rest of the fields. This user, as you can see, this is a very basic class. So we'll be adding a schema decorator from the NestJS Mongoose. That's it. So we can pass the options and all. I'll just cover that soon. And now as we'll be using this entity across the whole application, so it's better to export the type of this user entity. And that will be export type. Let's name this as user document equals to hydrated document, that is from Mongoose. And then pass the user over here. Hydrated document is basically helper type to get the user document type. That's it. And then we need to export the user schema, and that is created from the schema factory and from the class create for class, and we need to just pass user class. That's it. Okay, and also if you can see, we can cover the one part, that is index. So email, we can make it as a unique index. How we can do, from this user schema dot index, and the key is email, and this should be unique. That's it. So whenever the Nest server starts, we can actually pass another option so that if indexes has not created, it will automatically create. And for that, we just need to mention over here in the schema decorator. I think it's auto index. Yeah, true. That's it. Now that we have completed user entity class itself, let's jump back to the user service file. Remember, we used an in-memory users array as a database. Now as we'll be using the actual database, so we can remove these blocks. So after removing this, somehow we need some interfaces so that we can actually do some queries, either reads or writes onto the database. So what you can do, one way is you can normally inject this user entity into this user service and do all the necessary operations. But with my experience, at least I see that for the NestJS applications, a repository pattern is very good idea. This repository pattern is a design pattern that abstracts data access logic from the business logic, providing a clear separation of concerns. This pattern allows developers to create a separate repository class that handles all the database operations, making the code more modular, maintainable, and testable. So now, instead of using user entity class directly in the user service, we first create a user repository class and we'll inject that user repository into this user service, and we'll be using all the functions from that user repository. It is very easy if you understand the pattern. Let's start by creating a class first, and that we can create under the users folder. Users repository.ts. We'll start with a very basic class definition. Repository. Okay, first let's make this as injectable so that we can directly inject into the user service or any other service. So first thing we need to do is inject the user model, that is user entity, into this users repository, and that we can do similarly how we inject services into the controllers, and we'll be using the declarator for the same inject model. If you can see inject model, that is from again NestJS Mongoose, and we need to pass the model name, that would be user dot name. We can just pass like that. Okay, let's just make this as private and let's make this as user model, and the type over here would be any cases, that would be model of generic type user document. If you can remember over here, we just define the type, right? The hydrated document type that we'll be using over here as a type of this user model. That's it. And I guess this hasn't resolved properly, so let me just import this, and that's it. Okay, and the basic functions will be covering our CRUD operations, and also in the app.user.controller we haven't covered the other parts like put and delete. We'll just close that loop also in this video. So let's jump back to the users repository, and let's just start with find one. And from here you will be noticing async await pattern, because from now on we'll be using database IOPS, and that will be obviously asynchronous. So async find one. Okay, and the first part is we'll be making a bit more generic, so we'll use this as filter query, and the type would be again filter query that's coming from the Mongoose, and we need to pass the user here. And also we can use projection as a second parameter. Let's make this as optional. And for the type, we'll be using typescript's record utility type, and we'll be passing string and unknown. And the reason is we really don't know what type of key values we will be expecting, and also later in the video we'll move this to a base repository, so we'll be making a bit more generic. And the return type in this case would be promise of user, and the function would be this dot user model dot find one, and we just pass the filter query and projection over here. That's it. Let's just close the sidebar also, and let's just copy paste this find one, and we'll define find method. And if you can guess, this will be user promise, and over here we simplify. That's it. Now and then let's move on to create, and we don't need these two parameters. It would be user entity of type user. That's it. And user, and over here, and it will be user model dot create. Just remove everything and we just pass the user over here. That's it. Simple, right? And let's go to more function, that would be for update and for delete. And for the update, maybe let's just copy this pattern over here, and let's just name this as find one and update. That would be similar to the current helper function. Let me just update this one right away. So find one and update. That's it. Okay, and the pattern would be filter query. Instead of projection, we'll be using user, and also if you can guess, this will be user type, but it can be partial. So let's use again typescript's utility type partial of user. Okay, let's just pass user as is, and by default Mongoose find one and update won't return the updated user object. We need to use the third argument for it, and we need to pass true. That's it, so that it will return the updated document, not the previous document. And finally, last function would be delete. Delete one for now, and that would be filter query, and you can just remove the second argument, and this would be void. Okay, and also we can replace this with await, and this would be delete. Self-explanatory. Okay, that's it. So in summary, we created users repository, made it as injectable, and we defined all the basic CRUD functions. Let's just start now. Let's see if there are any errors. Start them. So it runs in watch mode. Okay, so there is an error over here, because there are quite few. We only specific user service. All right, I think we can just remove this also, because now we'll be injecting the user repository inside the user service anyway. So let's just remove this one, and you guys can ignore the all the errors for now, and let's just do the same pattern to inject users repository over here. I will read only repository and that is users repository. That's it. Okay, and for find all, now instead of returning the users array which was in memory earlier, we'll be using this dot users repository dot find. That's it. And we can pass an empty object for now, and also change this to an async, and this would be promise. Okay, ignore the errors and all for now. Let's just try to close the whole loop. So for the find one, we'll be using this dot users repository dot find one, and we will be passing this underscore id, because underscore id of user id. Let's just make this as async and promise. Okay, and also for create, we don't need all this. You can just return this dot users repository dot create, and then just pass the user object over here. And this one also, make this as async, and the return type will be promise of user. Simple. Okay, we got only 3 functions for now, but let's just close the loop on the users controller also. So over here, and also here also, let's just change this to async, and this would be of promise. Oops. All right, so let me just quickly paste this. Okay, let's just use till now over here, and this one also. Promise user. That's it. Okay, and let's just complete the loop for these two also. So first let's just use this over here, and we'll define the rest of the functions. That would be update one, and that would be update one. Just pass user id, and for the put we need data from the body, so we'll be using body decorator. User, and this would be sort of update user dto, and let's just create this one as well, similar to create user dto. So that would be over here. Let's just duplicate this one and rename this to update user dto. Also rename this to update, and also we don't need email to be updated as an example. Okay, that's it. Now moving back to user controller, let's just pass, and let's just pass update user over here, and this has been not defined. Let's import. That's it. Okay, let's just cover the delete also, assuming we have the function already. Just dot user service, that would be delete one. That's it. And let's just pass user id. Simple. Okay, and also here let's convert this to promise void, and over here async. This is also async. Promise of user object. That's it. So let's just complete these two function definitions as well in the user service over here, and that would be again straightforward. This would be update one, and over here first of is string. This would be update user dto. That's it. And over here this would be find one and update user id, and let's just use this as actual filter underscore id user id. That's it. There is an error over here. Return type user is missing the following tab. Oh, I think we define this as user array, which would be actually user. That's okay. Let's go back to user service, And let's just define delete one as well. Users controller delete one, yeah. Rename this to delete one, and we just need user ID to delete, right? So says await delete one. Oopsie, delete one. There are over here. And let's say, are there any errors now? Okay, we have one error. Nest can't resolve dependencies of the user service. Please make sure that the argument is at index 0 is available in the users module context. Self-explanatory. So we defined this one user repository, but we haven't actually included that as a provider in the user module. So let's just add that over here. Over here, users repository. That's it. And now we got this another error, that is Nest can't resolve dependencies of the users repository. Please make sure that the argument user module at index 0 is available in the users module context. So now if you can guess, if you just directly use in the providers, it doesn't work because this is actually part of the Mongoose user module. So there's another way of importing that user module, and if you can guess, we have separate block imports over here. So we'll be using this block now. That would be Mongoose module for feature, and we need to pass the models array. Okay, so let's begin with array, and that will be of object. So name user dot name, and schema would be user schema. That's it. Okay, now if you see, the server has actually started and all the routes has been already loaded, and Nest application successfully started. Simple. Okay, so now just to make sure if everything is in sync, let's just close everything, and we'll begin with users controller. The changes what we did over here are to cover the rest of the CRUD operations, that is like one put example and one delete example. Okay, so let's move on to the services. So in the services, instead of using the in-memory array that what we covered in the previous video, we are using all the user repository functions inside these each user service functions. That's it. Okay, and in the users repository, self-explanatory, here the actual data access logic is being covered. So this is completely abstracted. So if you want to write some unit test cases for the user service, you can actually mark the user repositories. Now in this specific example, as you can see, there's a similar pattern as one-liner patterns, right? From the controller, you're just calling user service one method, and inside user service also you're just calling one create function of the user repository. Again, this is for the sake of video, but usually if you can correlate, for most of the service functions you will have a lot of business logic, so that will be over here, right? And there will be before and after this line also, and this specific service can actually use any other repositories as well, like any other MongoDB collections. So again, if you see this users repository, this will point to users collection. So let's say as an example, if you have other collection like orders, so we'll be having orders repository. Again, if you can think of, we'll be anyway having the separate orders module, and inside that we'll be having controllers, repository, services, and all that stuff. And you can import orders repository into the user service if you want to check something like that. I hope this is clear till now. If you love this content, make sure you hit that like button and subscribe. Now let's do some end-to-end testing. Let's spin up the Postman. I'm not sure this font size is better. Let me just increase. I hope this is better. So let's start with get users, and I already created a collection, so we can just save some time. Let me just decrease it one font size down. Now let's just hit send. Alright, so we got an empty array, and also let's just check in the database as well. Fine, it's all empty. Okay, now let's just create a user object. So that will be post user, and over here I just created this one, name Vivek, email vivek@nestcc.com, and age 27. Let's just hit send. Okay, 201 created, and we got this object. Just slightly increase. Okay, you can see. Let's just look at the database side also. Let's just click find. Okay, we got one record. Let's just change this to JSON view. Okay, I hope this is clear. Now let's add another user object, and let's just use Vivek1 and Vivek1 with the NestCC age 27C. So now total 2 users should be there. Let's just do at the database, and now let's just check get users. Okay, we got 2 over here. Clear? And also if you remember, we defined email as a unique index. So let's just check that by directly using shell over here. Users get indexes. As you can see here, we have email as a key for one of the index and unique is true. So let's just test that also. So if you just use the same email and just click send, we got an error as 500 internal server error. But let's just look at the logs at the server level. Here we found E11000 duplicate key error collection at NestJS users collection. Okay. Of course, we can improve on the error responses, but for now, this is just to showcase how we can just simply define the indexes over here, and that will automatically reflect because we have the set of indexes as true. That's it. All right. Let's just cover the other set of operations. So we just tested post and get. So let's just test user ID based search. With user ID, let's replace this with the correct user ID object ID. Send. We got this Vivek one at NestJS. That's it. Okay. Now let's just update also for the user. Second user, this is the correct object ID. Let's just change a name to Vivek22 and age also maybe 28. Send. Okay, it is updated and we got 200. Let's just call get users. And for the second object, name is Vivek22 and age is 28. Okay, now let's just delete this entity as well. User ID. Send. Okay, we got 200 and let's just go back to users. Let's just click send. Okay, we got only one user, that is the first user. And user ID, if you just use this one, we got 200. Somehow this is off. Let's just fix this one, which is kind of straightforward. So in the users controller, we got this. Oh wait, we already have this user check over here, but it's not. Oh yeah, of course. So we need to change this to the proper await, so we get the actual user object instead of promise object, which doesn't resolve immediately, but of course it will return the promise object over here, which is not in a resolved state, but this check will not be true. So as we added await, let's just check this. Send 404 not found. That's it. Okay, we can actually use the same check for the also, but and it's very basic, and let's just skip this for now. All right, so now if you see here the pattern, let me just increase the overall view for the users repository. Now we defined all the basic CRUD operations. Now if you can look at the bigger picture, this find one, right? If you see here, the whole operations, the whole definition of this function can be a bit generic, and this can apply for any collection. Let's say if you have billing, orders, or posts, anything like this, like the extra another collections as an example. This pattern, we might end up having the same repositories, same syntax, same structure, just that this user model and this user return type would be changing, and also filter query. These placeholders would be changing. Rest all will stay as is, right? So what we can do, we can create a base repository, and we'll be extending that base repository with users repository, so that we don't need to have this boilerplate same generic code which can be applied for all the other MongoDB collections and for that respective repository files. So to begin with, we'll just create a common folder over here in the root folder, and also we can have another folder, repositories for now, and inside we'll be having base repository.ts. Maybe I'm thinking if we can rename this to entity repository, that is more ideal, I feel. Entity. Okay, let's define the class, and this will be an abstract class. Entity repository, and we'll be using a generic type. We'll be passing the entity model. Like in our case, we'll just pass the user entity, but imagine if you have orders or post entity, we'll be passing that, and we'll be using the generic pattern. Extends document of Mongoose. Be careful. So this is over here. That's it. Okay, now we define the constructor where the first argument would be the generic entity model. Protected read only. Let's name this as entity model. of type model from Mongoose, and we'll pass the generic over here. That's it. And now let's just define all basic CRUD operations. And I see I opened user service, which doesn't make sense. We should open users repository. So let's just open that. Okay, now let's just copy the function as is and just replace users with the generic T. That's it. Let's just import filter query, and I'm using control space, so I'll get this auto populated imports, and I'll just hit enter. That's it. So it gets added automatically. And over here, instead of user, we'll be passing T, and if you can guess, here it will be entity model. That's it. So with this generic, we just defined find one function, and which can be applied for any repository. Let's just follow the same pattern to cover all the other functions as well. Find over here, this would be T, and instead of user model, that would be entity model. That's it. Okay, let's just copy all the rest of the three functions. All right, and instead of user, let's name this as entity, and instead of user class, that would be generic. Model, entity model. Okay, filter query over here, that would be T, and over here this will be T. This one is also, and over here the, so for the user find one and update, maybe we can use as update entity, and let's just pass over here. Okay, and for the delete one, instead of user, that will be generic T. That's it. Clear? Let's just close user repository on the right side. And usually when you get users, if you can see, you're getting the version field also, which is kind of not really necessary. So what we can do, we can just change the entity repository, which will reflect for all the other repositories. So we can just update this projection in a way that, let's do underscore v 0, and let's just use spread operator over here. That's it. And we can just use this for the find one as well. That's it. Okay, now the changes won't reflect because we are still using the users repository, and that is defined with all the functions. So we can just blindly remove all these functions from the users repository, and let's just extend this with entity repository, and we need to pass the user document over here. And as it's a derived class, we need to call super user model. That's it. So all the basic CRUD functions are covered in this entity repository. We just need to use this pattern. That's it. Okay, and you can remove this filter query, which is unused over here. Now let's just test this out and also see if there is any error. Okay, here we got one error for the user service 21 line. I see. Okay, so in the create, if you see at the generic, we define it as T. As we pass the user document over here, and it is trying to correlate this with the actual create user DTO, where we have just 3 fields, and also one is optional. So it can vary. So we can just safely use unknown over here. Everything is in place. Alright, the server has started successfully. Let's just call users over here, and as you can see, underscore v is not in the response. That's it. To wrap up, I'll just go over all the changes what we covered in this video. First, we installed all the necessary modules, and in the app module, we define Mongoose module import, and we pass the MongoDB connection URL. And again, this is just for this video. Usually this will be loaded from the env or from the config, and again config values will be derived from the environment variables. And in the user entity class, we declared this as a schema with the help of this decorator, and also we exported a user document because this will be used across the whole application. Though we defined as a schema decorator, we need to use this create for class so that we'll get the actual user schema entity, and on top of it we can use this index function to define this as an email, and which is a unique index. And also we passed this option auto index, so whenever the server starts, it will check all the indexes that are defined in this user schema are in place or not. If not, it will create the indexes accordingly. That's it. Later we defined all the other functions also, and we closed the loop by link updating those. Later I created the users repository without this entity repository, but you can just refer from this entity repository where we defined all these 5 functions, and those directly we are using over here, and this is again linked to the users controller. That's it. And as a best practice, we actually defined a base abstract class that is entity repository, and we defined all the basic CRUD operations with a generic pattern, and we extended this entity repository for the users repository. And this pattern will be applied for all the other repositories that you might create for all the respective collections. That's it. And you can define all the other custom functions for the specific repository file. That's pretty much we covered in this video. If you feel this video is helpful, make sure you hit that like button and subscribe. Thank you so much for watching, and I'll see you in the next one.